Good week 11 Friday. Agenda today. 3 mole circle. Then I'm going to do a very extensive example on 2D mole circle. Then I'm going to introduce you to 3D mole circle. I put down there why. Okay. So I want you to appreciate what we can do with 2D. And then we're going to move over to 3D. The why is to show you the limitation of 2D mole circle. And be made aware that there are some visitors over here. I will not convince you to come to mechanical. You do what you learn. Why are you in mechanical engineering? All of you. Why? I'm here because I'm partial colorblind. Right? I told you guys, right? Chemistry I always fail. Mix a solution. What is the solution? What color? Can't tell. We are here as mechanical because of what? Mechanical engineer. We need to what? See to what? Believe. Can you see magnetism? Can you see electricity? You can't see them. That's why you're here. Mechanical. Right? Do what you love. Don't do what the economy tells you to do. Right. So the first thing we're going to do an example. So we have an element right before. Okay. So this is our element. And then we're going to sketch our transformation. This is our X. And this is our Y. Right. So we're going to look at this as a 2D problem first. Okay. So on our X, we have a stress, a normal stress going out at 100 megapascal. And then in the Y direction, we have it at 60, or maybe I make it 40 megapascal. And then we have positive shear. This is our 20 megapascal. Okay. So what we usually do, we label this as point X. And we label this as point Y. Okay. Then what this question want to determine is we want to find the stress state when the plane of interest has been rotated 30 degrees clockwise from the horizontal plane. So we want to determine the stress state or the element stress state where the element is rotate 30 degrees clockwise from the horizontal plane. Okay. So the 30 degrees is from Y, right? The Y over here. So we are going to call this plane Y30. Okay. That plane is going to be our what? Y30. So from here, we construct mole circle. Later on, I will expand this question to 3D, okay, by using the same circle. Okay, so now we sketch. Okay, so now we start to sketch mole circle, horizontal plane, is our normal stress, and our vertical plane is our shearing stress. Okay. So this is our shear, and you all know now the shear, this is element rotate clockwise. Over here is anti-clockwise. So this is 0, 20, 40, 60, 80, 100, 120, and then here minus 20, minus 40, minus 60. Then on the positive side, make sure the scales are the same again. Okay. So from here, we understand that normal stress X is at 100 megapascal. Normal stress Y is pulling out is at 40 megapascal. The shear XY, which is equal to shear YX, and this is going at positive 20 megapascal. Okay. So from here, we can construct our mole circle, or we label some points that we need to know first. So we know that point X sees a normal stress of 100. Okay. So this is our stress X line. And then our stress Y line is at 40. So comes to our stress Y line. Okay. It's at 40. Stress Y line. And as I mentioned before, the shear, you have to look at both what? No doubt it's positive. You have to construct them both positive 20 and what? Negative 20. And I'm going to show you that the protocol we're going to use is exactly the same like what I told you all on Wednesday. So the first thing we're going to identify is we're going to identify where's our point X and where's our point Y. So I want you all to focus on point X first. Okay, point X, which I'm highlighting yellow, and I'm highlighting the arrow over here, and I'm highlighting the normal stress of 100. So the normal stress of 100, you know, stress X is, you can see, is on 100. Now, point X can be either at positive 20 at the top, okay, or at the what? Bottom from the zero normal stress line. So what determines whether it's at the top or the bottom? It all dependent on the what? Rotation of the element. Okay, so what do I mean by that? If I were to put my finger, or if we were to pin the center, okay, by pinning the center, you can see the highlighted shear arrow over here is going to generate what sort of rotation? Anyone? Clockwise or anti-clockwise? Counterclockwise. So counterclockwise, so this is counterclockwise, so this is our point what? Point X. Now we draw attention to point Y. Okay, we draw attention to point Y. So at point Y, if you see over here, is we are dealing with the 40 megapascal. And then this pink that I just highlight at point Y will induce a rotation of the element clockwise or anti-clockwise? Clockwise, right? So that's why clockwise, this is our point Y. Okay. So from here, immediately you can start constructing, you can draw a straight line. Okay, you can draw a straight line. Okay. Right, so from here, I might change my question a bit after I construct my mole circle, okay? But let's focus on here first. So from here, we can calculate our stress average. Our stress average is also equal to the center of circle. So your stress average is equal to stress X plus by stress Y divided by what? Divided by 2. So we are going to have 100 plus by what? 40 divided by 2. This is equal to 70 megapascal. And as you can see, by constructing our Mohs circle, where the XY line intersect the zero normal stress line is exactly at, or zero shear line is exactly at where? 70 megapascal. Okay. So from here, I'm going to label this distance over here. From the zero line, this is our stress average. Okay. From here on, we know we have to calculate our tau max. Tau max is equal to the radius of circle. Okay, radius of circle. So to determine our tau max, real straightforward, this will be equal to 10, 20, 30, 30 squared plus by what? Plus by the shear. The shear is equal to what? Is equal to 20 squared. So this will be equal to 30 squared plus by 20 squared. So it's equal to 36.05. So where I am now, 36.05, why 30 squared? We know that what we want to determine is the radius of the circle. So if I were to construct the radius of the circle, this is going to be the radius of the circle. Okay, so to find the radius of the circle, we are aware that this is the height, or this is one of the geometry to determine the radius of the circle. This is equal to 20, and the distance from here to here is equal to what? 30. Okay, from here, we determine the radius of the circle, okay, which we already did, and it's sitting at 36.05. So from here, we can also identify our stress 1 and stress 2, which is the what? Principal stress. So on the principal stress, the shearing stress is equal to what? 0. Yeah, I'll put bracket. Shear stress is equal to 0. So when that's the case, stress 1 and 2 will be equal to what? 70 plus minus 36.05. Okay. So 70 plus by 36.05 is equal to 106.05. And then will be equal to minus 70 minus 36.05 is equal to 33.95 megapascal. So from here, we can construct we know the points of principal stress. So this is just a sketch. This over here is our stress 1. And then another point, 33. This is just by eyeballing. This is our stress 2. And then we know that our maximum shear is at 36. Okay, so 36 is somewhere around here. So this distance over here, this is our tau max. Okay, so from here, we can construct one of our circle. Okay, so 36, okay. So come to here, and then go to minus 36, somewhere around here. Okay. So this circle belongs to our what? Belongs to our XY plane. Okay, this belongs to the XY plane. Now, because of, I want you to learn something useful over here. Okay, so I'm going to change the direction of the plane. Okay, I'm going to change the direction of the plane. I do apologize. I did not know. I did not prep today's lecture. Okay, my bad. but I'm going to do something, okay, which will not affect your life too much. So what I'm going to really. Okay, so what I'm going to do is I'm going to wipe this off. Okay. The reason why I'm doing this because I want you all to